Ravi, thank you for the opportunity to talk about the future of manufacturing. It's something that I'm really passionate about. However, before I dive into the future of manufacturing, a couple of disclaimers. I'm not going to be talking about robots, and I'm not going to be talking about 3D printing. So if you were hoping to hear about how robots are going to take over manufacturing or how 3D printing is going to take over everything, you're going to be disappointed. What I'm going to focus on, though, is how do manufacturing companies view the future of manufacturing? So I'm going to be talking about more of a perspective from the standpoint of manufacturing companies, whether it's automotive, consumer packaged goods, oil and gas, metals and mining. So we're going to look at manufacturing a little bit differently. This is an area where there's dramatic change occurring today. And I call it the hidden factory. The hidden factory is coming out today. And it's being really created by all of the data that's not being utilized. So if you look at a typical manufacturing plant, what it does really well is control. Control of the process so you can repeatedly produce consumer packaged goods, automobiles, or whatever. So we perfected that, and that's working really, really well. What the systems in manufacturing do not do today is they don't collect energy or optimize it. They don't collect diagnostics information to predict when things are going to fail. So there's a whole host of information that's available which is untapped. In the past, manufacturing was pretty much isolated from IT systems. But now with IT and manufacturing getting more integrated, the opportunity for leveraging this information, by the way, there's lots and lots of data involved, is tremendous. So I'm going to talk about that aspect of manufacturing. I'm also going to dispel one other myth, which is IoT is taking over manufacturing, which means every sensor that lives in the manufacturing environment is going to read the data into the cloud. Magic is going to happen in the cloud, and it all comes down from there. It's not going to happen that way. So with those disclaimers and that introduction, let's dive in real quickly. So as you look at manufacturing, there's several macro trends that are accelerating investment in manufacturing. Global competitiveness. It's becoming very, very important because most companies have to produce and serve customers globally. We're living in a flat world. The cost of production is coming down. So you've got competition from a lot of emerging countries where the cost of manufacturing is much lower. The larger companies have to respond to that. Talent shortages and skill gaps. A lot of baby boomers, as we know, are retiring, so there's a lot of talent shortages. A lot of what they used to do is getting automated or is getting put into knowledge bases. Manufacturing more and more is becoming a regulated industry. We are all familiar with regulations in pharma and food. Regulations are also very prevalent in all the other manufacturing sectors, including automotive. Also, IoT is making an impact, and we'll talk about what type of impact IoT is making. So when you look at manufacturing today, these are exciting times, truly exciting times for manufacturing. And because of that, you're seeing a lot of country initiatives. If you look at the world, there are many, many country initiatives that are focused on manufacturing. We've all heard of Industry 4.0. We've heard of China 2025, or Made in India, or within the US, smart manufacturing. Just last month, the US government funded a new initiative, $300 million over 5 to 7 years, to reproduce, to manufacture human tissue. Rockwell is the exclusive automation partner in this effort. It's being led by Dean Kamen, who is the inventor of FIRST Robotics, who's the guy behind FIRST Robotics. Some of you may know Dean Kamen. So manufacturing is a big deal. In the US alone, we're investing billions of dollars in smart manufacturing. All of this money that's going into smart manufacturing is really focused on leveraging what I'm calling the hidden factory, leveraging the information that's sitting in manufacturing, but it's not being leveraged today. So really, really major opportunity here. So at Rockwell, we call this vision of future manufacturing as the connected enterprise. So the connected enterprise really is to take data from your production environment, manufacturing environment, link that data with the data you've got in the enterprise, the rest of the enterprise. That could be the supply chain, that could be logistics, that could be your warehouses, customer demand. And the whole objective is to link this data to optimize what you do in production. And I'll give you some examples. So let's hold that thought for a second. Let's talk about what is the connected enterprise all about. What it comes down to is optimization. So if you look at manufacturing companies, you hear about them talking about a perfect order. When they say a perfect order, what they mean by that is, as a consumer, let's say I go buy a bag of potato chips at a grocery store. They want the customer experience for buying that bag of potato chips to be very good. When you go to buy that bag of potato chips, perhaps taking a coupon from your Sunday paper, you have to find those potato chips on the shelf. If they're not there, you're going to buy something else. So having a satisfied customer and working that backwards through the supply chain, all the way to raw material, and optimizing cost, optimizing quality, optimizing efficiency, labor, and environmental factors. Environmental factors include energy, waste, etc. So a perfect order is an end-to-end optimization. That's what the connected enterprise is all about. This is really what smart manufacturing is all about. So we talked about AI in the previous panel. Here's an example of what AI could do in smart manufacturing, a practical example. Let's say I have multiple plants, and I'm just looking at the energy consumption in my multiple plants. I can very easily create a dashboard, as shown in the right-hand corner here. So what I want to do now is, this exists today. I can look at energy consumption, energy cost by multiple plants. What I want to do now is, if I look at plant 1 and plant 2, and I find that plant 1 or plant 2 is roughly 30% higher in energy consumption per case of production, I want a deeper dive. I want artificial intelligence or some machine learning system to tell me, why is it that plant 2 is at a higher energy per case? So if I were to apply artificial intelligence, or I were to apply some type of cognitive computing here, and I can tell the operator or the plant manager that the reason plant 2 is higher is because the clean-in-place process is consuming more energy. You're not bringing the plant back up after you clean the plant. The light balancing needs to be much significantly improved. And here's the cost of doing it. Click this button, you get that done. So this is a deeper dive into figuring out what subsystems in the plant are not working efficiently, making a recommendation, and then making it actionable. So smart manufacturing is all about business value. It's all about delivering business value and delivering it in a way that it's not being done today. So what's happening in manufacturing? Machines are getting smarter. So a lot of computing is going into machines. If you look at a typical controller that sits in a machine, it has a quad-core processor. It has a Windows 10 module, typically. So there's a fair amount of computing that can be done directly within the machine itself. So the machine is able to collect the data. It's able to associate the data with the machine state, which is called contextualization. It's able to do some simple analytics and report those analytics, right? So those analytics are best done within the machine itself. Because the insight here is, if you do the analytics within the machine itself, you can change your control settings. If you run the analytics in the cloud, I don't know of a single customer who will allow you to change settings in the control system from the cloud. So that's the advantage of doing analytics where the data is being generated. So let's talk about some of the technologies that are impacting manufacturing. What's making manufacturing smart? The first thing here is Ethernet. If you walk into a manufacturing plant, you see a plethora of proprietary networks. All of these networks are migrating to Ethernet. The cost of connectivity to Ethernet, cost per node, is rapidly coming down. It hasn't crossed the field buses that exist in manufacturing yet, but it's getting close. So today, more and more plants are implemented using Ethernet, both wired as well as wireless. An important concept is scalable computing. If you look within a plant, within a manufacturing plant, there's significant amount of computing available, whether it's in the control layer or within a server. There's tremendous amount of computing available on the edge. So leveraging that computing for analytics becomes an imperative. So again, the fact that you're going to do all analytics in the cloud, that's really not happening. Because you've got scalable computing, because you've got the ability to process data and act on it very quickly, and analytics are being implemented mostly within the plant itself. So if you look at how analytics and future manufacturing is going to get implemented, a typical manufacturing plant is made up of several subsystems. So one way to look at a plant is to think of machines which could get configured in lines. The lines make up a plant, and your multiple plans make up your enterprise. So you need to implement prediction, optimization, and actions at each one of these subsystem layers. So think about your car. Your car is made up of several subsystems. So if you think about your automobile and say, okay, I'm going to do all my oil-related diagnostics in the cloud, and I'm going to tell the car when to change the oil from the cloud. Does it happen that way? No. Because your car itself, has enough sensing and computing available to tell you when you need to change the oil. There's really no reason to pump the data from every sensor in the car into the cloud to do processing. So a lot of subsystems are able to analyze and do some analytics locally and provide actionable business value at different layers. So this is how analytics are being implemented. This is how we see smart manufacturing evolving. So you ask, well, there's a lot of excitement about the cloud. Where does the cloud fit? The cloud has a very distinct role. It does provide a significant discontinuity here. And it is in comparing line performance across multiple plants. So if you've got a pump, for example, in plant 1, you've got a similar pump in plant 2 and plant 3 and plant 4. If you're able to compare the performance of these different pumps and optimize them, the only way to do that would be to get the information up into the cloud. So the cloud is really good for analytics, for optimization of performance across plants. So this is really a key concept that smart manufacturing is coming up with, which is important to distinguish as opposed to this thinking around all data is going to go to the cloud. Just a really quick slide on the technology stack. I'm sure there's going to be one or two engineers in the audience. So just for a couple of people in the audience, at every layer, you need gateways, you need stream processing, you need data modeling, you need a way to persist the data, and you'll be implementing analytics, reporting, and mobility at every layer. So this is kind of tech stack that gets embedded at different layers in the manufacturing system. And there's a lot of innovation that needs to be done in these different layers, how they come together, how do you incrementally build your data model, how do you persist the data, how do you manage the information. So a lot of work to be done. I think there's a lot of scope here for startup companies to innovate this whole process around enabling what I call the hidden factory. So one of the key concepts here is IT and OT are coming together. We're all familiar with IT. OT is the real-time environment. It's where everything is happening in real time, not transactional systems. But IT and OT are definitely converging. I can't go to a meeting these days without having an IT person sitting together with an OT person. I'd say about 10 years ago, that was oil and water. They would never sit together. But today, more and more, IT is getting involved in manufacturing and the evolution of the OT side. So this is not something one company can do, and that's why I put this chart up. You have to have an ecosystem. This ecosystem includes large companies like Rockwell and Cisco and Microsoft, but it also has to include a large number of smaller companies and startups. So that ecosystem is now evolving and getting built up. And this ecosystem has to produce solutions by industry vertical. Because unlike other areas, manufacturing tends to be very industry specific. Applications are very different. So the solutions that the ecosystem produces has to be by industry vertical. So to wrap up, well, I didn't talk about 3D printing or robotics. If you look at what's happening in manufacturing, today manufacturing is modular and secure. Secure is a relative term, obviously. It's going towards becoming more predictive and optimizing. We talked about an optimized connected enterprise, and in the future, it's going towards becoming more self-adaptive and self-healing. So that's a very quick overview of where manufacturing is going. I know we have a couple of minutes. I wanted to finish up in about 15 minutes and open it up for questions.
Thank you very much for this presentation. I'd like it if you could put this in a broader context. So I'm the general manager of a manufacturing plant.
Okay.
I'm not, but say I were.
Say I were the general manager of a manufacturing plant. I see a bunch of technologies described here. Most of them have been around for a long time in one form or another. To me, this seems doable. I can implement this quarter, maybe. That's what I'm reading from this. How do I know whether this is an investment I should be making? And am I doing it to cut costs? Am I doing it to compete more? How do I evaluate this proposition?
So, very good question. So there are two types of companies that I'm seeing today. One group of companies are stuck in trying to figure out the infrastructure. How do I manage the data? How do I secure the data? How do I integrate my cloud with my plant? What kind of firewalls do I need? They're stuck in trying to design the infrastructure. More build it and they will come type of a model. There's another class of companies that are saying, okay, I'm going to find out where my biggest pain points are. If I find that my machines are running at 60% duty cycle, so downtime is a major issue for me, can I focus on downtime? Can I get business value by implementing smart manufacturing just for downtime? Let me run a pilot for that. So we're seeing those types of pilots. We're doing about a dozen right now, where leading companies are saying that here are some of my pain points. Can we very quickly build solutions so you can demonstrate business value, then we'll worry about the infrastructure. We'll evolve it as it comes. So the pilots are focusing on problems like uptime, machine uptime, predicting when a machine is going to break down. They are focused on energy optimization. So there's a whole bunch of areas that companies are identifying where they're doing pilots to take care of pain points and get immediate value, and in the process, implementing the IT/OT convergence and the connected enterprise.
Just a quick minor follow-up. If you had to make a list of the top 3 to 5, I don't know how many, the issues that are most frequently targeted with this kind of technology, are they energy, uptime? What are the sort of the biggest use cases?
So the biggest use cases are cost, reducing waste, which fits into the environmental space. Cost and waste are kind of related because the more waste you produce, the higher the cost. And then you've got uptime, machine downtime. Uptime is a major pain point. Energy is not just electrical energy, it's water, air, gas, electric, and steam. It's called wages. So it's that whole bundle of energy that's used in manufacturing. So these are some of the major areas.
Given the last 25 years, we have seen product development, product design, and manufacturing basically shifted in 2 different places, right? Do you see that it has lost out the fact that the engineering is done in one place and manufacturing in a different place? Do you think the industry has lost out ability to improve the manufacturing technology faster, unlike in the olden days, right, where everything has to happen in the same place? So engineers have to incorporate a lot of the manufacturing capabilities, and simultaneously the manufacturing technologies also improve. So that's question number 1. Question number 2, right? Given all these shifts that is happening, do you see that manufacturing coming back to the United States?
Okay. The second one is more difficult to answer. The first one is easy. So the first question, if you look at engineering and design, being separated from manufacturing, physically separated. Well, that doesn't matter anymore because your product lifecycle management systems, your ECAD and MCAD systems are now totally integrated with manufacturing. So when you design a product, you design it in a computer-aided design system, for example. That design migrates all the way into the plant. So if I make any changes on the plant, it reflects back into your design. So they're no longer decoupled. So if you look at an ECAD system, electrical CAD system, where you do all of your electrical layout of the factory, that electrical layout is now integrated with the plant. So if I'm a maintenance person, I walk up to a machine, I can see the ECAD drawings immediately. If I make a change, the ECAD drawings get updated. So it's all now electronically integrated. So the physical separation is no longer an issue. Your second question about manufacturing coming back to the US, maybe we'll talk about that over beer later this evening.
But going back to the first question, there was an article Andy wrote a few years ago about how the manufacturing innovation lost out because the two got separated out. I'm just curious to understand your thoughts.
So I think he was right, because in the past when manufacturing got offshore, you had very little visibility into quality, into productivity, how well the manufacturing process is doing related to the design. Not true anymore. The design and manufacturing have come together again. So you've got simulations in the middle, you've got complete integration with design engineering and manufacturing. So that bridge has been built electronically in software. So today, that's not an issue anymore.
Thank you.
Thank you.
Thank you.